Thank you very much. I want to talk about Jazzperiments, and that's a project which is running over some time already to make interactive music. And it's already started, as you hear. The whole idea was originally that we wanted to do something with effects and sounds while I was playing the clarinet. Well, you see a lot of keys on these instruments, and it means that when you want to play extra sounds, like a bass part, which is already running, then you need pedals or something. But the whole idea was, what's the more natural interface for music than a microphone? And that's what we did. We hooked up a microphone and we started, experimented to make automatic improvisation, automatic accompaniment and things like that. I can give you a little example already, what happens when you play a clarinet with this computer program and how it sounds. So the computer listens to what I do, Fourier, it processes the sound in a very intelligent way, thanks to Carl Helgason's Java sound engine. I'll switch off the microphone for a moment. And you have a kind of system which allows you to play interactively. In this case, it plays a bass part while I'm playing the clarinet. And you hear that it follows me. Of course, you have to do with latency. The thing doesn't know what you will play, so it has to measure it, and that takes time. And that was one of the big problems with all kinds of automatic improvisation and interactive music, that latency causes delays which you can hear. Well, is this the maximum speed? No, it isn't. You can play a lot faster. For instance, when I play now, you see the metronome is going faster too. Now it's already in sync. Can I go even faster? Yes, I can even go faster. When you go to the top speed over here, now it uses all the power it has to calculate things. You get this. But you see what happened? This is the maximum speed. It doesn't do anything with the musical speed anymore. What it did at the previous speed, it was a short presto note. What it does now is maximum speed, and it's out of sync. You get a kind of idea that the delay is even more nasty than the previous one, although it's almost half as short. But a good kind of being too late is better than being just a little bit too late. And that's the idea behind a lot of thinking in this program. So you see already a metronome on the screen and a computer and a keyboard of a piano, and you see all kinds of instruments mentioned there and intervals, and you can do something with always musical terminology, musical theory. There is a lot of computer theory inside this program, but there is also a lot of musical theory. So this latency stuff, that you try to solve the latency problem by playing in sync, although it's a little bit too late, which is better than just as the maximum speed. That's a musical approach. The same you can do with the accuracy of the whole system. You hear that it's quite accurate already, and that is because it doesn't recognize all notes. It only filters out the notes you want to recognize, and it converges eventual problems with intonation of a clarinet to notes which are there in the scale, as you can see on the piano keyboard on top. Of course, in most music you don't use all the notes which are on a piano, so you can even converge more, and that you do like this. Now we had a chromatic scale, and for instance, when I choose a blues scale, my piano gets all kind of great keys at top. So these notes aren't there anymore. So it can't make a mistake in that respect. And when I play now, I should play in a bluesy style. But then you get another solution for this problem. of tonality. Well, see, now the notes on the keyboards even changed because it notices that my first note was a C and that it has to switch the scales to the right to play the right scale over there. In fact, what you do in this way is that you can make a kind of presets of accompaniment and play quite freely. We did a lot of experiments with kids and in schools. You can play quite freely and the computer always plays something which is, well, more or less agreeable. You can handle it. It's a way of adding extra voices to when you're singing or when you play a clarinet or something. It is actually kind of accompaniment, and of course there will be improvements possible. I will come to that later, but it's already quite useful in that respect. I can give a little impression what you can do more do with the system. For instance, when you have you can choose all kinds of intervals. You can set that it will play an octave lower or higher than what you played. It can play in a certain octave always, so that when whatever height I play, it plays notes in a certain scale, plays it back. And even what you can do, you can invert it. And now you get a very strange effect. When I play high, it plays low, and other way around. That was low. You see this red note going up and down, and it's just fun to do. It's on the website. It's a Java application, and you can just start it, and it's fast enough to play with a reasonable computer. You need kind of good microphone. When you do it with the built-in microphone of a laptop, you get feedback, and it's not as nice as when you have some kind of microphone, but any microphone of fewer euros is good enough. So this is the idea behind automatic improvisation, automatic music making. And of course you have talk about using technology to make more or less a new musical instrument, but that's nothing new. People have always used technology to make music. This instrument is built in the 19th century. At the beginning of the 19th century, we had two little copper keys to close some holes. Now you see there are 18 of these on it, and that's technology of the 19th century. And you can be sure that it has a lot of hacking to get this done. And when we have to do some hacking to use computers in a nice way for music, that's, I think, a very good idea. Of course, you can also go to experimental music, and the previous talk I liked very much, because then you have a completely different approach to music, more experimental. And in fact, you can do that here too. We use a lot of MIDI notes in this program. As you see, all the notes which you heard until now was MIDI. And also from the Java sound library of Karel. So you have a nice set of 128 instruments you can use for everything you want. But the idea was also, what can we do with samples? And how can we record samples in such a way that you can use them in music? Well, I showed you that. Sorry for windows in between. Strange sounds, or everything made just right now. And it's even possible to continuously record new samples. For instance, when I go, let's see what we have here. Now it will automatically record new tonal samples in this green voice. So we have 4 voices. 2 voices are noisy now. That's a kind of percussion. That's just because I handled the microphone in a destructive way. The first one is this sample of the tuning fork, and the last one is now, for instance, my voice. Yo. And you can put them in also in time. You can move a sample. Sometimes it stops, sometimes it doesn't. But you see that this is more of a much more creative, but also much more unpredictable way to use your instruments. But of course you can use it in many ways. We did a project on John Cage last autumn. And then we had not only this very technical, musically technical interface, but also other interfaces to use. For instance, here you show the notes in harmony. Now it connects notes to the voices which are playing those. So every voice had its own character, and he uses a part of the song, so you can see which note was played in which voice when you're fast enough, but it's just fun to look at. Another one is this is another display which I like a lot. No, there's another one. This is the one we did for John Cage's project. John Cage created this music notation because it's so intuitive, and he made it for a very nice piece called Aria in 1952. So you see that new music isn't like the last speaker isn't that new. And I think we have, when you love music, you have also more or less the responsibility to think of new things in that respect. Of course, this program, we worked quite a lot of time on it already, but there are lots of opportunities to improve it. First of all, these algorithms, both musical, what is smart to do when you have delay, where you have to cope with, or technically, new engines, better programming for reducing latency or other things. But there are other things which I think of it could be very nice. I love it, the idea that a user interface for music is a microphone. You don't need anything else, no pedals, no buttons, no stuff. But the camera inside the computer could be used for tempo indications, let's be clear, when the director is for an orchestra, he uses his hands just to make gestures, and why couldn't a computer recognize those? Other things you can think of is that there is special hardware for Fourier analysis, so which is built to measure as fast as possible the frequency of a note. You could use that too. So everybody who likes this idea and wants to anything to do with it or to work on it, you know the website. It's in the little booklet, and Jazzperiments. When you type in the name, you will find it soon enough. When there are any questions, just ask them. Maybe there are some people who want to do something with it. Yes?
I've done a bit of music on the JVM. One of the classic problems is GC pulses. Do you find you get problems with GC pulses introducing artifacts into your music?
More or less, but the man sitting right behind you knows a lot more about this technical stuff. Carl, can you please answer this question?
You have to be a little bit clever when you're using Java. You have to make sure you reuse as objects as much as possible. Let us little carefully, as you say.
What in practice, in using MIDI notes, there is no problem with latency whatsoever. So it's fast enough simply because these notes are played, and when they are played a millionth of a second too late, and you saw what trick I do, that I just play them on the right time in the timing of the music, you don't find anything troublesome in that respect. Latency in that is caused by the fact that the computer recognizes the voice too late. And that's something that has to do with the type of instruments even. With a wind instrument, each note you recognize is too low when you start, because the pressure isn't built up yet. And with a percussion instrument or a piano, every note you play starts too high because it hits with a lot of overtones and dampens a little bit out. So latency is inevitable. But there you have a different kind of latency. And what Carl said, when you make samples, of course, these samples are recorded at the moment that someone isn't singing. Then I switch off everything, take a sample of what I hear, and moves on. Oh, sorry, it's taken at the moment that my program isn't playing anything. So then I switch off everything, listen to what the player is doing, and then make a sample of it. Also very handy that you never have feedback. Yes.
Rather than trying to play with you,
that's true. In fact, what you can do is and I can pick the setting. You see that here we have you have on the bottom you have that the scale can be selected automatically. When you know what you want to do, you don't want an automatic scale. You choose one, and you have a choice of scales with. Well, a little bit part of the screen is fallen off, but there are about 80 different scales from Egyptian, Dorian, chromatic, blues. Of course, it's very well known, but we put everything in it. So when you say, I want to play in the blues scale of C, and you go, then you have a very accurate recognition because it only recognizes the notes it will use. And the speed is also a little bit better because you can be in the recognition of the notes, you can be a little bit less accurate because you know that there are bigger intervals between the notes.
Have you done anything with progressions? Like a blues always has, what is it?
There comes this automatic stuff in. When you play, what I did was I play the C, then with this automatic switching, it knows I have to start in the scale of C. Then I can leave a little pause after, for instance, 4 bars, and then move to the F and play a little bit, and it follows it again. But I must say, it's this is you have to really get used to it. So when there's this intuitive playing where you just let it follow, and most of the time I use then a whole tone scale or a chromatic scale, which is always right or not right, but always works, and they have a lot of freedom. Whereas, but I work with a group of people who sing Gregorian chant at the moment. They know exactly what they have to do to fix all this. So, and they write music to sing along with this thing with their own voices.
I'm curious on one thing. I tried. Are you making some sort of split between the voices that you are recording? Before you were playing something,
Yeah.
and it was assigning to one.
Yes, that's quite simple.
How is the logic of this?
The logic is that you have, and you can see that over here. It records notes manually. Then you have to switch this little button, and it records in this voice, a red, a yellow, a blue, or a green voice. There are maximum 4 voices. That's technically almost the maximum you can process. And so you can switch to note manual, note once, note automatic. That means that it will take tonal information, only record it when you want it, record it once and then keeps it, or record it every time it has the chance to record something. And the same applies for noises, so you can do percussion too. That's different, processed in a completely different way, by the way, because yes, you can't transpose it and stuff like that. But so you can switch, for every voice you can switch to manual noise, manual note input or something like that.
But you decide when to switch. You can't recognize 2 different voices playing at the same time. I mean, if there is a percussion and a clarinet playing, you can't.
No. When you want to organize this, maybe you shouldn't, because it's nice when things happen by chance. But when you don't organize it and 2 people play at the same time, you have a mixed sample. And it's put in one of these voices. You can of course say, when this, and you see this white ball there, that's the red voice is now ready for recording. When I say you play the red voice, then I have to keep my mouth shut while you are doing something. But okay, we did also in a museum with kids, and everybody was thinking, on this time, nobody knew who was who in that case. Yes?
You played with letting it feed back into itself, so it plays along with it.
Mm-hmm.
Is that interesting at all?
Yes, it is interesting. You heard right now, it did it. Of course, it depends of how this setting is not ideal, and with a little bit correct microphone, you don't have this problem. But it can, when you change the settings a little bit, it can play for hours without you being there even. Any other questions? You see, a lightning talk is long enough when the subject is interesting. Yes? I'm over time? Oh, okay. Thank you very much for your attention. Oh.